Yesterday, I needed to send a letter to a colleague, so I went to the front office and asked for some postage stamps. At the front office, the staff gave me a sheet of 12 stamps that formed a rectangle, 4 stamps wide and 3 stamps high. Conveniently, the stamps were numbered 1 to 12. The staff member there told me that I would need 4 stamps to send my letter, and that I could take any combination of these 4 stamps, as long as they were all connected by an edge. For example, I could choose stamps 1, 2, 3, and 4, or I could choose stamps 1, 2, 5, and 6, or even stamps 1, 2, 3, and 7. However, I couldn't take stamps 1, 2, 3, and 8 because stamps 3 and 8 were only connected by a corner and not an edge. Now, I must admit the front office stamp policy is a little unusual, but the whole event got me thinking a little mathematically. So, your task today is to find out how many different 4-stamp combinations are possible with this 12-stamp array. Remember, the rules from the staff were that you could take any 4-stamp combinations as long as all the stamps were connected by an edge. Corner connections don't count. Have a try and see how you go. Do you need a hint? Well, I'll tell you this. The total number of possible 4-stamp combinations is greater than 50, but less than 100. Have another try and we'll walk through the answer in a bit. To solve this problem, we're going to use a combination of 2 problem-solving strategies. Firstly, we're going to create a table so that we can record data about the different 4-stamp combinations. Our table is going to have 3 columns, 1 to list the different combinations, 1 to record each occurrence with tally marks, and 1 to write the total as a number. The second strategy we are going to use is to draw a diagram. Now, each of the 4-stamp combinations can be represented by a 4-square diagram and placed in the first column of our table. Let's start with the most obvious 4-stamp combination, that is 4 stamps in a horizontal row, such as 1, 2, 3, and 4. Firstly, we're going to draw this shape in the first column of our table, and then record tally marks for each instance of that combination. In this case, there are 1, 2, 3 instances, so let's write 3 in our final column. Next, let's look at the 4-stamp combinations that form a 2x2 square. For example, 1, 2, 5, and 6. From our diagram, we can see that there are 6 instances of this combination, so let's record it on our table. Now, this is where things get a little trickier. The previous 4-stamp combinations we looked at only exist in one orientation. If we flipped or rotated them, it wouldn't add any new combinations to our tally. Let's look at the combination represented by the numbers 1, 2, 3, and 7. There are 4 instances of this combination, so let's add it to our table. However, if we flip this shape horizontally, we can create an entirely new combination represented by the numbers 1, 2, 3, and 5. Let's add this shape to our table. Again, there are 4 instances of this combination. Now, if we flip our 1, 2, 3, and 7 shape vertically, we get another combination with the numbers 5, 6, 7, and 3. Again, let's add these 4 instances to the table. Finally, if we flip our 1, 2, 3, and 5 shape vertically, we get another combination with the numbers 5, 6, 7, and 1. Again, let's add these 4 instances to the table. Notice how we have created 4 variations of the same shape just by flipping. Rotating and flipping this shape creates even more combinations. Let's jump ahead a little. Here is our completed table of all the combinations and instances. To find our total, all we need to do is add all the numbers in our far column, which gives us an answer of 65. So there you go, there are 65 possible ways to tear off 4 connected stamps from this 12 stamp array. I had no idea it would be so many. We hope you enjoyed putting your stamp on this playful postage problem. Thanks for watching. We'll see you soon.
Hey there! If you like what we do here at Teach Wonderful, make sure to subscribe to our channel. You'll also find plenty of amazing teaching ideas, student worksheets, and merch over at teachwonderful.com. Thanks for watching. We'll see you soon.